This conference will now be recorded.
A very good afternoon, dear students. I am Ashok Kumar, your math tutor. And today in this session, we are going to learn about number system, right? It is also important for us to understand how we use numbers in our daily life. For example, I'm saying that I will be taking this session for 5 to 7 minutes. Then I'm using 5 to 7 numbers here. For example, I'm saying I want to eat the pizza and I have ordered a pizza in which I have 8 slices, out of which I want to eat 2 slices. That means I will be eating 2 by 8 of that pizza. For another example, we can say weather report of Dehradun is saying, suppose the chances of rain is today 50.3%. That means again we have a number that is 50.3. So we may have different categories of numbers. We may have integers, non-integers, rational, irrational. So let's understand all those things by using an image. I have prepared one. So we have real numbers here, and real numbers can further be divided into rational, to integers, to negative whole, then non-integers, then terminating and recurring, and then in the same way we may have irrational numbers. Let's try to understand all those real numbers in a number line. Okay, so I'm creating one number line here. I will try to cover as much as possible. Okay, and whenever I will see that time is about to complete, I will end the session. Okay, in between. So here we have 1, 2, 3, and 4. These are known as natural numbers. Then if I include 0 also, then including 0 and these natural numbers, we can say these are whole numbers. These can also be known as positive integers. Okay, these can also be known as positive integers. Then if we have positive, then again, then we may also have negative integers. So here we may have -1, -2. In this way we can plot these negative integers in number line. So these are negative integers. Including 0 and all positive integers, we have whole numbers. Then we have one question whether 0 is positive integer or negative integer. So 0 is neither positive nor negative integer, right? Now, why these integers are in the category of rational numbers? What are the rational numbers? Rational numbers can be written in the form of p by q, where q should not be equals to 0. Why? Because if we have any number like 1 by 0 which have undefined solution infinity, so we cannot count this as rational because it is not defined, right? Now, why integers can be known as rational? Because if we have any integer like 2, 2 can be written in the form of 2 by 1, which is the form of p by q. That means these are rational numbers. That means 2 is a rational number. Now, let's take another examples to understand about non-integers of rational and then terminating and recurring. For example, I have a number 1.2, I have a number 1 by 3, and I have a number 2.5. 2.5 can be said as decimal number or fractional number. If we try to solve this, then we will get 25 by 10, which is in the form of p by q. That means it is a kind of rational number. Here we have 1.2, which is in the form of p by q. That means it is also rational number. If we try to simplify it, we will get zero point 0.5. If we try to solve 1 by 3, we will get 0.3333. That means 3 is repeating here. So in this case and in this case, we have two things. It is terminating the decimal because we have got the final result. But in this case, we have not got the final result. As we can see, the 3 is repeating. We can write it 0.3 bar or zero point 0.3 dot. So in this case, decimal is not repeating. That means it is non-terminating. It is terminating. I'm writing T for this and NT for this, non-terminating, right? Also, we can see 3 is repeating. That means it is non-terminating recurring. So we can write 1 by 2 for terminating, and for recurring, we can write 1 by 3. It is non-terminating and recurring, right? If we have the problems like let me give you one another example for this. If we have problem like 1 by 7 or 19 by 50 and 48 by 150, then how we can identify which are terminating and which are recurring? So we have a very simple for that. We can solve these and we can get the results of these. But what is the problem? If we start to solve this, it may take time. So we should have some trick because calculators are not allowed in the classrooms in the examination. So what is the trick for this? Any number whose denominator factors are only 2 and 5 can be known as terminating. For example, factors are only 7. That means that are two, not 2 and 5. So we may get here non-terminating. Okay. Then in 19 by 50, the factors are 2, 5 and 5. 2 5s are 10, 5s are 50. That means we have the factors only 2 and 5. It means it is the terminating solution. If we will try to solve 19 by 50, we will get 0.38, which is terminating. In this case of 150, what we have 150, that means 2, 5, 5 and 3. We have the factors 2 and 5, but also we have one factor that is 3. That means it is non-terminating, right? So this is the point how we can identify the non-terminating and terminating recurring without using calculators. It's a short trick. Then next we have irrational numbers. Irrational numbers, non-terminating and non-even recurring, non-terminating and non-recurring. For example, I think time is about to complete. So I will conclude it as soon as possible. I'm taking one example, root 2 and root pi. Sorry, only pi. Pi can be written as 22 by 7, but still it is not rational number because it is not the exact solution. It does not provide the final value endless because 3.14159 so on, that means non-terminating and non-recurring, and that means the value of root 2 is 1.41421 endless. So these are known as irrational numbers because these have non-terminating and non-recurring values. And the main thing is how we can know about the non-terminating and non-recurring, how mathematicians know about these things, because they have tried to find the solution million of times on supercomputers or MATLAB software, because it is not feasible for us to find out the solution in normal calculator. So we'll do this much for the day. Thank you. We'll meet on next session for next part.